Alright, time for another DraftPhysics.com, DebatePhysics.com also, video presentation. So kind of an update video for the website, and then I'll do some comments. Haven't been many, and they're garbage. Yeah, it's just not very relevant. So anyway, there has been a few videos on the website I think are pretty good. So I have decided to write 2 books, so to speak. This was I listened to a couple of audiobooks and they only took about 7 hours. And you're saying this is a few hundred pages worth of text. And most of the book is just a bunch of talk about nothing. It doesn't really, who died when, who was who, all this kind of name dropping crap, personal information. It doesn't really do the science part or the physics part. Doesn't illustrate the experiments well at all, frankly. And so I should be able to do this, frankly. In like 3 hours of video, let's say, make the 2 arguments that have to be made, right? And the other part of it is their books don't deal with all the counter arguments. The books are just this assertion. We've proven, it proved. They always say the Young experiment proved, verified finally, decided, blah, blah, blah. So they just argue from, without doing all the counter arguing, without responding to all the counter arguments that could be presented. And so yeah, that makes it easier. And I guess it makes it to some extent more authoritative and all of that crap. Now, I'm not looking to be an authority and to win the argument by default because somebody thinks I know what I'm saying rather than knows I know what I'm saying. So that doesn't mean much to me. But clearly that's how the Al-Kaharis and the rest of these people, that's how they write. They write as if they know the truth and there's no doubt about it. And they have the right answers and they're going in the right direction and all that kind of crap. And I don't find that personally appealing as a way to argue. But whatever. So there's 2 books to write. There's the book where I just make my assertions and pretend there's no counter theory. And I just point out how, see, the model works. Okay, you start with these simple ideas and you can explain everything. And there'll be no woo in it. There'll be no bent space, and there won't be any entanglements, and there won't be any superpositions, and there won't be any Heisenberg, and there won't be any of this nonsense. Won't be any extra dimensions or any of that crap. And then the second book is just pointing out at every single turn, at every time science has a choice, they screw it up. Just about, right? I mean, can't even get plus and minus wrong. They say light is bent twice as much by gravity. They haven't even proved it's bent at all. Double slit nonsense. They don't even know what a beam splitter is, and yet they're telling us they saw gravitational waves. I mean, it's all just crap. Alright, and so that'll be the second book. It's just to point out that why are you believing what these people say? Because they really don't have any hard evidence for any of it. It's all just speculation based on little tiny, little shadows they saw moving in the trees. Oh, there, Sasquatch is real. Little cigars in the sky. Oh, so UFOs are real. I mean, it's just that bad. Any excuse to make up a phantasmagorical, special wooey religion, frankly. It's just another frickin' religion. And so that'll be the second book. Yeah, alright. So anyway, that's the strategy. So in that vein, I started the first chapter of the book that will something like, there'll be a title, there'll be something like It's the Small Universe After All. I mean, it's something to do with the fact that there's only one universe, and there's only one place where there's actual things, that aren't made, composite objects, cities and all that kind of stuff. There's actually bricks in the universe. You can go to brick, and there's an elemental universe, and that elemental universe is so abstract. We're so abstract from that. We're just a bizarre manifestation of that universe. And anyway, so in that one runs on these simple rules, and that's the real physics. So identifying the rules that run that universe are the rules that are really reliable. So anyway, so in that vein, I'll play a little bit of this video just to rub it in your face or so. You know, it was a good video, I guess. I think it'll be improved with time. I can only see parts of this little universe. Okay, so I probably have to increase that and decrease this to reduce the echo, I imagine, anyway. See if it works out that way. We can't see everything. Can't see it. Yeah, you can't, you know, we know we can't sit there and see the small universe, so we can only model its function, model its outcomes, and find a way of creating something simple that creates those outcomes, some simple cause and effect diagram. And I think the simple one is that there's stuff called force that's moving the speed of light, the speed of force, because it's the same for all the forces. All have the same speed, therefore, yes, deducible, they're all the same thing, and they're just manifestations of the same things, just circumstantially different circumstances. So charge is a little circumstantially different than magnetism, electricity, and gravity, but it's all the same stuff. And there's just rules about how the force interacts with the matter. Period. Done. Yeah. And thought we'd be going like 1/7 and 1/8. Alright, so the idea is that the matter has to absorb the force's energy. That's how the matter moves. And so it can never go the speed of light because, or the speed of force, because the force is entirely responsible for the production of its velocity. So it would be like arguing that if, you know, you had a robot that went 30 miles an hour and what it did was push objects in the universe, that somehow it would be possible for it to push an object as fast as it's going or faster. And you know you couldn't do that. You can't do that in the physical world. If you had to move things bigger than yourself, or things that doesn't even matter whether it's smaller than you, if you had to carry 1 more pound with you, you know you're not going to run as fast. So if, you know, you're a road racer or something and you run a 4-minute mile or whatever, you know, if I add weight, I'm not going to make you go faster. You're going to go slower, and you're always going to be slower than the speed of the force. And so it doesn't matter how many 4-minute milers I put behind the car, they can't push the car faster than the 4-minute mile. I mean, it's not that hard to figure out why there's a speed limit. There's a speed limit because the force has the momentum, it has the velocity, and the matter has to be pushed in their position, because as they gain momentum in a direction, that pushes them into a field with other electrons. Right, so the oscillation part is just a part of what it's like the energy in the universe is already a rubber band. Okay, so no matter what something does, if it goes into the energy, it's going to get a reaction that's going to dampen that response. Now, it's not going to cause an opposite effect immediately, but you can just understand that if there's a universe with so much stuff going this way and so much stuff going this way, that yes, you could have a place in the universe where something's going this way because it's being pushed by extra stuff going that way, or because there's less stuff going this way. But you'd understand that for every one of those circumstances, there's somewhere else in the universe where there's extra stuff going this way and less stuff going this way. So that's the equal and opposite reaction, but it's really not as Newton stated it. It's a little more, you have to say it a little more carefully in these directions. All right, and the tendency would always be to oscillate. Right, so the fact that all the matter is vibrating inside of atoms makes perfect sense if you think of it as a system of magnets, and that if you jiggle one of the magnets, you have a bunch of magnets north facing and you have a little south facing one in the middle, and you put them between a piece of glass so they can't flip, you can understand they have this tension with each other and attraction to a center, and that you could create a system of magnets where, you know, you flick one of them and all of them end up jiggling, and the jiggle just keeps going. If there was no friction, you could understand that, wow, that jiggle really wouldn't go anywhere. It'd take a long time for it to be dampened out of existence. There needs to be contact to dampen it. You know, to take away the vibration, something needs to hit it. It's like the tuning fork would just keep vibrating if it wasn't for the atmosphere and the fact that something's holding the fork. But if I could put the fork in space and I vibrate it, it's going to vibrate a very, very long time. A very, very long time. Because there's nothing in contact with it to absorb and pull that energy out of the system. That's in the universe. All the little bits moving are pressure. And so anytime matter moves in that pressure, there's going to be an opposite reaction. Yeah, the opposite reaction is the extra reflection it creates in the opposite direction. So if this moves forward, it's pushing energy in one direction. It's expanding energy in the opposite direction. And there's a yin to that yang, so to speak. A photon is not an object. It's not a... So this is like a key thing. We have this vocabulary that is so broken. So yeah, it's a really good word, photon, you know, to describe the idea that the energy is in pieces, and but it's all broken because even in the wave theory, it sort of has to be understood that the wavelength, you know, the photon isn't an object. There's not a mile-long wave somewhere. There's not a 5-mile-long wave. You know, it's, you know, the logic says that the easiest way to make that frequency or that wavelength is to have a pulse and then wait a while, have another pulse, and then you wait a while and you have another pulse. You know, one continuous wave would be, you know, diluted out of existence over long, long distances. So this is about sending a code, a dot. You know, there's no dashes, there's just dot. Okay, you got a dot, dot, dot. How fast the dots come is the code. I mean, it's such a simple concept. Photon is not an object. It's made of things. It's a composite. It's an event. Photon is an event. Electricity is an event. It takes time for electricity to happen. You just don't instantaneously have electricity. All right. So, you know, by the matter, so all the coinage of the energy, all of the. All right. So, you know, I think it's a decent enough analogy to just point out is that the energy you can think of as money, and you're just saying that there's, you know, you can lose your money by having contact with somebody and you give them your money, or you can lose your money. Well, that's really the only way you can do it, you know, by contact, by experiencing, by interacting with things that don't have energy and they take it from you. Or you can interact with things that do have energy and they can get the extra can go into you. But that's all you're saying. You're just basically banging two cards in a card game and you're saying, well, I have a 7 and somebody else has a 9. Well, it'll get kind of averaged out and I'll gain a little and they'll lose a little. And basically all the exchanges in the universe are taking place under those rules. Things that have it end up disproportionately getting hit with things that have less energy than them, and therefore they lose their energy. And that's the whole entropy argument. Okay, that it's hard to hold on to extra energy because there's lots of things with less energy that will take it from you to move that funny way. Can cause. Okay, I don't know. This is the magnetism subject, so I just barely touched on it because I didn't want to get into the whole blue-red charge argument yet. So anyway, so it's just about the first chapter, the nature of motion, and not perfectly done, but you know, it's a start. A draft of the first chapter. The second chapter will be something like charge and magnetism and electricity. You'll probably just deal with charge first, because that's the thing causing the difference. So another video I did was a review of a book I listened to that was interesting, to say the least. I don't know if there's not a lot of physics in it, but there's a lot of history in it, and it's interesting history about all the politics of the 1700s, and, well, it doesn't really get into the 1700s, frankly, but so it's mostly Newton, Leibniz kind of stuff, and yeah, valuable in terms of understanding the characters and all that stuff. So I guess I won't bother playing it. Well, I can play a little bit of it. And, chasing bizarre answers to questions. So that was one of the disappointing things, is how, the religion thing was such a liability. And if you just think about how much time these brilliant minds wasted contemplating the possibility of the Bible being relevant somehow, I mean, what a waste of their time. I just, like, I don't know, Michelangelo making sandcastles or something. I mean, it's just, ooh. I mean, at least that would be good practice. There's no good, you don't gain anything by studying the Bible except a headache. I mean, it's just gibberish. Mindless, silly nonsense. Because it's using a lot of energy heating the ramp, the friction. Right, so that was just talking about Galileo and using the ramp, and the interesting thing is yeah, you can slow down the fall of something, and so it's in the gravity a longer time. But the catch is, to slow it down, you're pulling a lot of its cash out of its bank. So yes, it's gaining more money, 9.8 meters per second. You could say that's $9 every second. But every second it's giving a bunch of energy to the ramp. So it's losing, for every $9 it gets, it loses $4 kind of thing. So over that period of time, you might double the amount of time it takes for it to go from point A to point B, point A to point B. In terms of height, you might double the amount of time it takes for it to fall, but you also double the amount of stuff it was, you also increase the amount of energy it was losing to friction through that whole period. So it was supposed to get 9.8 and only got 4.4, or 5.4, 4.9. So instead of 9.8, it got 4.9, because it was giving 4.9 to the ramp. So yeah, it was in the gravity twice as long, but it wasn't free falling. It was losing cash as it was falling, and therefore it needed to be in the gravity longer, because it was losing cash the whole time it was in contact with the ramp. Interesting physics, in my opinion. Or further from the sun when you're real physics. Speed changes, and blah, 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 blah. So probably something about orbits and why it's ellipses. And so I did talk some about the fact that, these equations are always based on you going from zero to being in the gravity, the orbit. And the trick is, if you want to get into a circular orbit, you can't do it that way. You can't come in from the outside, because you won't go into an orbit. You'll either get flung back out, or you'll crash into the thing in the center. And if you start on the Earth, your velocity is not consistent, and therefore your orbit won't be circular. The importance of, say, calculus versus the... Yeah, so there was a lot about calculus, and like it was somehow the perfect physics idea or something, and it's, to me, it's just a tool, and it's a tool for engineers. It's really not a tool for scientists trying to reveal the truth. It doesn't reveal some kind of truth about how things work. It just gives you answers to questions about, well, what would happen in 45 years from now? Where will the moon be in the sky? Well, yeah, it's an interesting question to somebody who needs to know, but it's not going to tell you how the physics works. So to me, it's not all that. It's, it's like tang. It's a nice side effect, but it's, it's not what we're after in terms of modeling the universe. All right. So the other video was probably just a comment video, yeah, and so we won't bother with that. And then the other one was the Bohr model of the atom, which is, you know, in my opinion, just complete garbage. They got it backwards in so many ways. First, these things aren't spinning around. Atoms are semi-static, no orbiting. Makes for much better bonds between the atoms. And the other thing they got wrong is I still don't quite understand how they think the higher energy orbit is the outside orbit. And you're like, duh, no, that's the weakest orbit. That's the furthest distance from the nucleus. The electron is bound by the weakest interactions. The energy between the electrons at great distances is weaker. That's the weak bond. The strong bond is the one on the inside. That's the one with lots of energy. So it's when an electron goes from the inside to the outside that it gives off a ton of energy, not when it goes from the outside to the inside. So they got that part all wrong. Again, plus and minus wrong. They just got it backwards. Wave particle. They keep saying wave. Now it's particle. They got it all wrong. Alright, so I'll take a pause and we'll do some comments. Alright, should be back. Alright, it's a book review video. For every second you are falling, you have to add 9.8 meters per second to your speed. Well, why isn't it seconds squared? Hence the 9.8 meters per second acceleration. So again, per second means what? How do you write per second? Squaring 9.8 meters is certainly retarded. Squaring the number of seconds that's in the gravity is retarded. So, I mean, you're just saying something that doesn't mean anything. Okay, so I'll finish. Same as meters per second squared, of course. So, has an event happening once every second means I square the seconds. So if it's 4 seconds, it's 16 seconds. What is that? How does that make any sense? The clock ticks. It goes tick, 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 tick. 4 ticks. I square it. Why? Why would it make sense to square how many seconds? So he says every 12-year-old has to give themselves some time to grasp the idea and let it sink in. So any 12-year-old knows that if something happens twice as long, it's really happened 4 times as long. And if it happened 4 times, it really happened 16 times. So every 12-year-old knows that if something's in gravity twice as long, it gained 4 times the energy. Every 12-year-old knows that if it's going twice as fast, it is going really 4 times as fast. It's 4 times the energy. Twice the amount is now 4 times the amount, and 4 times the amount is now 16 times the amount. That makes sense to you. Well, it makes no sense to me. It's absolute garbage, and you can't link me to a single piece of evidence defending it. And you continue to not link to any evidence. So show me, and then I'll argue what you show. But you show nothing. You don't show the thing dropping twice as far, or 4 times as far, twice the velocity, twice the time in gravity. You don't show something falling twice as the time in gravity, making 4 times the dent in the ground. So until you do that, you have no argument. Alright. Every 12-year-old says, show me. Prove it. You just talk the same shit over and over. You will not respond to any counter-argument made to you. You just keep saying the same stupid shit. Hey, per second means squaring the number of seconds. Why does it mean that? Per second. Okay, saying something happens, and you're using seconds as the way of measuring. That somehow I should square the number of seconds for arbitrary reasons. Why don't I say the event happens a certain number of times per second works. per second squared is not saying the same thing. They're different statements. Alright, in short, so this was previous to the other idiotic comment. Alright. A certain spring has an amount of potential energy. So again, I've already argued that the word potential doesn't mean much. There's active energy in things, and you can tap that active energy. Gravity is an active force, not a potential force. Alright, when released, every different ball receives the same amount of kinetic energy. It receives the same amount of energy. The spring stores an amount of energy, kinetic or momentum, it doesn't matter. That's the argument, shithead. The argument is you're silly 1/2 and you're silly squared. Those things don't mean anything in the real world. That's the argument being made. So you can keep asserting that you have ownership of the word energy, but you don't. Okay. Every different ball has a different momentum. So this is idiotic. So this, Professor Lewin will tell you, you can't say that. That's unscientific. That's against all of their evidence and all of their understanding. They'll tell you, no, nature can finagle kinetic energy. It can't finagle momentum. So again, you're arguing against all of your own authorities. Your authorities will tell you you can't say that. Different momentum doesn't fucking happen because you have to always conserve the momentum. Oh, fuck you. I mean, this is just such crap, you type. Therefore, the spring has a fixed amount of energy, but no momentum. Therefore, because you say so, in contradiction to your own scientists that you're apparently the own conventional theory that you're defending, that doesn't say what you're saying. You're just making shit up. Soon to be blocked. I mean, frankly, this is such, you keep typing the same tripe, and who gives a fuck what your little character was? The point is your argument was stupid. Alright, you can convert newtons into joules. There's no law against it. You can understand a joule as an amount of foot-pounds of pressure. No law against it. Shit. Alright. So that was it for the website comments. Ugh. Alright, now for the YouTube comments. I mean, inane crap, so IRF, whatever the fuck that stands for. Why does the moon spin on its axis? It's not the subject of any of these fucking videos, idiot. Alright, I mean, it says right in the thing, interview with Veritasium, 2-slit experiment. Is there something in there that's going to have anything to do with the fucking goddamn moon's spin? Okay, so obviously the moon, you know, this idea that it spins on its axis, okay, it means relative to the sun, okay, it spins on its axis. Obviously relative to the earth, you know, well, relative to the center of the earth, you could say it's making one rotation per orbit. But you can sort of understand that the gravitational body that's relevant to the moon, the one that's most relevant, is in fact the earth. And I think any moron could do some of this deduction on their own and say, well, yeah, the closer the object is to the other object, that is, the higher its velocity and the closer its orbit, the more those influences they're going to influence each other in terms of any, you know, tidal forces, and the rest of it are going to have a reciprocal effect. There's going to be a yin and yang, a tug between the two, because the earth is going to respond, you know, its tidal movements are going to be slower. They're not going to be instantaneous responses to the moon's tidal effect. And therefore, they're going to push and pull on each other in uneven portions of time. When this thing's peaking, this thing hasn't peaked yet. Okay, so it's not going to peak until after the peak, you know. And so the fact would be is over time, they would tend to dampen the movement of each other. Because they wouldn't be reinforcing it in any harmonic way. Okay, there wouldn't be any complementary resonance to their pulling on each other, and they'd end up dampening the effect over time. So I think objects that don't have any spin at all because it's contrary to those effects, like the magnetic poles, different things obviously magnets orient, so you can understand why they're polarly not, nothing spins on its north-south axis. So yeah, you could figure this out yourself, but it's not the subject of the video, and it's a complex subject, frankly, because you have the tidal forces of the sun, you have the tidal forces of the earth, and then you have the other planets, and they're all going to affect how something behaves, and then time is going to tell. So we don't know how much the moon is spinning compared to how much it was spinning, a million or billion years ago. And frankly, it seems pretty, you could just do a little deducing to figure out that the moon is what created the continents on the earth. That the earth was in fact settled, and it just was covered in water, and the moon actually collided with the earth and bounced off, and left a big hunk of itself on the earth, and then that hunk of itself over time has broken into pieces and is sliding across the surface of the earth. I mean, it's not hard to model this reasonably, but this is not the subject. I'm talking elemental physics. I'm not talking some complex situation where you have to do. And so what do you think it means? Do you think it's one of these UFO things? UFOs invented the moon? I mean, why do you think this is at all interesting that the moon faces the earth because it's lost any real rotation to the earth? Because the rotation wouldn't be, they would be yin-yanging on each other too much. And so they would settle to be facing each other. You think that's a dramatic fact? Fuckhead. It's just so rude. You can't stay on the subject of the fucking videos. So I'm not going to 8 minutes and 30 seconds to find out what you mean a second and third dimension kind of thing. No, it's not a second and third dimension kind of thing. There's already 3 spatial dimensions. So what are you talking, a second and third dimension kind of thing? What does that even mean? All right, now, I mean, it's theoretically possible that hydrogen atoms are one-dimensional, that they have a shape. It's quite possible. And that the more complex the matter gets, the more three-dimensional it gets, because it has more axes of magnetic attraction, charge attraction. So complex atoms could have 6 poles, in the sense of they have 3 north poles and 3 south poles. That kind of thing is perfectly reasonable. But whatever, what is this little mushy shit comment? What is anybody supposed to make out of that? A second and third dimension kind of thing? Everything's a third dimension kind of thing. We really don't interact with anything in anything other than 3 dimensions, because it's the 3 dimensions that we are always stuck with. I mean, you view things that are one-dimensional from 2 or 3-dimensional viewpoints. We're looking at everything from a 3-dimensional perspective, so everything, no matter what it is 3-dimensional, just because we can't interact with it in any other way than 3-dimensionally. Oh, fuck you. Alright. You said electrons and protons are the boat, and the game really is that they're swimmers in the water, and they jump in the boat, and when they're in the boat, they're rowers. Yeah, it's a perfectly easy to understand analogy. That motion is in the ocean. You're sitting in a boat with no motor, and you don't row. Okay, you don't have any arms, whatever. Your arms are both broken. Who cares what the explanation is? You're in a dead boat, and you're in a sea full of activity. Okay, and the fact is that activity, when it's in your boat, it will row, and your boat will go. So whatever jumps in your boat is where you're going to end up going. Is that really that hard to imagine? You really can't do it. You can't understand it. You can't figure this out. It's too complicated. What's wrong with that simple metaphor for how the fucking thing works? Okay, who are these swimmers? I mean, fuck you. Who are the electrons? Who are the protons? Who are the atoms? Who are the sun? Who are the... yeah, there's material stuff in the universe, and we're basically saying, yes, it's a physical universe with their shit in it, okay? It's a fact that the universe isn't nothing, okay? It's full of something. The fucking point is to describe how the fucking something functions. Nobody can explain where they came from, or who gave birth to them, or any of that fucking horse shit. Alright, so again, just be as irrelevant as you possibly can. Just be a fucking piece of scum. You can't make a contribution to a video better than this. I'm talking in the video about momentum and inertia. Alright, and trying to explain to somebody how, yes, the game really is just as simple as there's energy in the universe and the energy moves the matter. Alright, is that too hard for you to understand that forces cause matter to move and that matter doesn't cause forces? Fuck. So yes, fuck you. Try again. Alright, and see if you can get blocked next time. Shit. God, I just hate people. Alright, so already did the dirty garage guy. He didn't respond to my comment. Who knows if he read it. So we'll just wait. I mean, he is having an argument with somebody about replacing the OEM, the holy OEM parts, that cost twice as much. And that, maybe you can just manufacture your own part out of a PVC pipe and you don't have to spend, 5 times as much for the part. Blah, 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 blah. And he's, sort of trying to make the argument that, no, it won't work, you can't possibly. It's just, in my opinion, he's on the wrong side of that argument. That, frankly, as long as you don't plan on crashing into any brick walls, the part will work just fine. And yes, if you crash into a brick wall, the part will fail. But it won't fucking matter because your brain is going to be smashed into the brick wall anyway. So whether or not a couple of parts on your motorcycle break won't make any goddamn difference because you're going to be fucking roadkill, you dumb fuck. So yes, if you endure 2 tons of force, okay, if you have an accident where you're going to endure 2 tons of force on your front axle, guess what? You're probably not going to survive anyway. Part failure could only be useful in a way, right? The more the parts fail, the more it might save your fucking life. Whatever. I don't think he's, so we'll see. But see if we can get him to talk some more physics. And, really, this is such an important subject to anybody who does any of this performance of any kind of mechanical machine or something. The fact that physics has this preposterous lie in it, that you're going to use 4 times more gas if you go 60 miles an hour than 30 miles an hour. I mean, all of these dopey notions about how much energy you have. You have 4 times the energy because you increase the velocity and you're going to hit the wall with 4 times the energy. No, you're really not. It's not going to happen. Okay, a 60 mile an hour crash is not going to be a 120 mile an hour crash. Alright. God, I fucking people. Anyway, alright, so that's the video. Yeah, so till the next time and such. I was surprised that the Veritasium, the 3 videos, 1 and 3 are on YouTube, 2 is on the website, and they weren't very well received. I mean, we said, ha. I mean, the humor was a little dry, and yes, I didn't cheat Veritasium in the sense I allowed him to do his silly evasions. Because that's exactly what he would do, is just evade all of the subjects. Because we know they can't defend these arguments. We know he can't defend bouncing 2 balls and saying that's the double slit experiment in water. No, it isn't the double slit experiment in light. The experiment in light is not about 2 fucking waves. 2 waves don't get any right answers. They don't predict the pattern. Those kind of things. But you can't back any, physics girl. I mean, I kind of directly asked the question. Do you really think 10-ton trains going 5 miles an hour would decisively lose a tug of war with a 5-ton train going 10 miles an hour? I mean, decisively lose. Do Do you really think if they crashed into each other, the 5-ton train going 10 miles an hour would just push that big heavy 10-ton train right out of the way? Because it has so much more energy. Come on. You can't be that stupid. You got to be able to see that, oh yeah, there's something wrong with that theory. That theory doesn't really make sense. That, I put a 10-ton train going 5 miles an hour into a lever over here. I can make the 10-ton train going 5 miles an hour on the other side. I mean, the 5-ton train going 10 miles an hour. 10-ton train going 5 miles an hour on one side. 5-ton train going 10 miles an hour on the other side. And somehow I made free energy. I only needed 100 joules to make the 10-ton train go. And yet I need 200 joules to make the 5-ton train go 10 miles an hour. How the fuck can I do that? How could that possibly be the truth? And you believe it, and you defend it, and you do all this bullshit. You assholes won't concede. Yeah, that's a problematic fact. That really doesn't make any fucking sense. How the fuck could the lever produce something that has twice the energy? Because it's not a free energy lever. But you will concede nothing. You'll produce no evidence, and you'll just keep defending rubbish. How are you not a religious kook? You have no good arguments, you have no good evidence, but you're going to defend the theory. Isn't that just typically religious? Ugh. But even that argument doesn't bother these people anymore because they are religious. I mean, the religious kooks have won. I mean, they're religious atheists. They're only atheists against Catholicism. They're not atheists against wooey, wacky, silly theories. They're just atheists against particular Muslim or Catholic. But they'll accept Sasquatchio, or UFO-ianus, any of that shit, they'll jump on that bandwagon. Fucking idiots. Ugh, God. Did I say I hate you? Yeah, I think I did. Yeah, I hate you people. God, you're so repugnant, stupid fuckers. Ugh.